All right, simplifying radicals. In simplifying radicals, we have two properties, and then we have three rules that we have to follow when we simplify radicals. The two properties, one is the product property, where basically if you have AB, the square root of AB, you can break that down into the square root of A times the square root of B. All right, so these would actually have, again, the whole symbol on it where they break down. So if we want to take a look at example, let's say I have the square root of, let's say, 400. The square root of 400 can be broken down as the square root of 4, all right, times the square root of 100, which again can be broken down into 2 times 10, which is 20. So that's the product property, that we can break things down. Also with the quotient property, very similar, and in this case what we would have here is, if we have, let's say we start off with the square root of A over the square root of B, and actually we have the square root symbol over both of them. All right. We start off with like that, then we can break it down into the square root of A over the square root of B. All right, we can break it down. Now let's take a look at an example. Let's say we have the square root of, let's say we start off like this. We have the square root of 9 over 25. Now one of the rules that we're going to have for simplifying radicals is that there cannot be a fraction underneath the radical sign, underneath the square root sign. So you're going to have to do this anyways. So what this is really saying is I can say, break this down into the square root of 9 over the square root of 25. Now both of these happen to be perfect squares. So this ends up being the square root of 3 all over the square, it ends up being the square root of 9, which happens to be 3. And it ends up being the square root of 9, which happens to be 3, and the square root of 25, which happens to be 5. All right, so we got to remember these two rules, the product property rule and the quotient property rule, as we do some examples on the next page. Now, if you haven't got these rules written down, you need to make sure you got these rules written down. Rules for simplifying radicals. All right, no perfect squares factors under the radicals. All right, and that's a pretty simple explanation. For number one, if I have the square root of 8, is there a perfect square that I can take out of 8? And the answer is yes. I can break this down as the square root of 4 times the square root of 2. Well, what is the square root of 4? The square root of 4 is 2 square root of 2, and that's your final answer. So when you're simplifying radicals, you look for these things to happen. You look to see if you can take perfect squares out of. Another example here would be, let's take 48. All right, square root of 48. If I have the square root of 48, I can break that down as the square root of 16, all right, times the square root of 3, which ends up being 4 square root of 3. Now let's say I didn't see 16. I could, if I went a different route, and let's say I broke this down as the square root of 4 times the square root of 12, which is also 48. And then I broke that down as 2 square root of 12. Well, square root of 12 has a perfect square still in it. I can break this down further as like this. And what is the square root of 4? It's 2, and I also get 4/3. So that's just, sometimes we don't always see when we're doing, we might not see the highest that goes into 48. So that's what we would get. All right, now, no fractions in the radicand. All right, so let's take a look at an example like that. So if I have a square root symbol, I have 7 over 16. All right, so I break this down as the square root of 7 over the square root of 16. What is the square root of 16? It happens to be 4, so I end up with the square root of 7 over 4. Okay. Now let's take a look at another example. All right, and in this example we're going to have the square root of 18, all right, over 3. Now there is no radical, all right, in the denominator, but 18. So now I got to look up here at 18. Is there a perfect square that goes into 18? And the answer is yes. So I can break this down as the square root of 9 times the square root of 2 all over 3. Well, what is the square root of 3? Well, it's 3 square root of 2 all over 3, but the 3 and the 3 divide out to be 1, and so my final answer here would be the square root of 2. All right, we're going to do a few more examples, all right, on the next page. All right, now, we have to remember those rules as we go. Let's take a look at this example right here. Let's say we have the square root of 80. Right, over the square root of 45. All right. Now, in both cases, we need to try to break these down. And in both cases, we can. We can take perfect squares. So the bottom would be the square root of 9 times the square root of 5, which gets us 45. And up top, 4 goes into 80, but 16 also goes into 80. So we end up with the square root of 16 times the square root of 5. Now, when I break this down, here's what I get. I get 4 square root of 5 over 3 square root of 5. And just like in the last problem, what is the square root of 5 divided by the square root of 5? That is 1. So my final answer here is 4/3. All right. Now, let's say we have another example. We'll call this an example, I think that was example 4. All right. And we'll look at example 5 here. As we look at example 5, we have square root of 20. All right, times the square root of 80. So we use our product rule, and we get the square root of 1600, all right, which happens to be 40. 16 is a perfect square, so 40 times 40 would be 1600. That one worked out pretty nice, but all radical problems don't always work out that nice. So let's look at example 6. We have the square root of 3, all right, times square root of 20, all right, over the square root of 5. All right, now let's use our product rule, and we have the square root of 60 all over the square root of 5. Now I cannot have a radical in the denominator, so to get rid of that radical, I'm going to multiply the top by square root of 5 and the bottom of square root of 5, and that will eliminate my radical in my denominator, because the square root of 5 times the square root of 5, all right, so we is 25, square root of 25, which happens to be 5. So I'm going to have 300 up here, and I'm going to have 5 down here. Now 300 can be broken down also as the square root of 100 times the square root of 3 all over 5. And we know that the square root of 100 is 10 square root of 3 all over 5. And again, in the same situation, 5, and our final answer becomes 2 square root of 3. 2 square root of 3 is our final answer. And one more example will do. All right. If we have the square root of 7 over the square root of 5. Again, trying to get rid of that radical in the denominator. Get rid of that square root. And to do that, you multiply by the square root of 5 over the square root of 5. And that's how I eliminate a radical, because 5, again, what we end up with here is the square root of 35 over the square root of 25, which happens to be 5. Now I have to look at 35. Is there a perfect square that goes in there? And the answer is no, there's not a perfect square that goes into 35. So there's our answer, square root of 35 over 5.